Hi everyone, today we'll be talking about tension, which is just another type of force. So our example is that we've got a 1600 kilogram car and it's pulling a 400 kilogram trailer. The car is producing 500 newtons of thrust from its engine. We've got to calculate the acceleration of the car and the trailer and calculate the tension of the tow rope and also calculate the net force. So let's do the first part. So we don't know what acceleration is, but we do know that the force, the thrust force, is 500 newtons, and that the mass of the car, so we're doing the acceleration of the car, is 2,000 in total. So that is the 1600 kilogram car plus the 400 kilogram trailer. So the whole system, the mass is 2,000 kilograms. So therefore we know that the acceleration must be force divided by mass, because F equals ma, which is 2,000 divided by, it's not 2,000, it is 500 divided by 2,000, which is 0.25 meters per second squared. Okay, so that's the first part. So the acceleration, because they're connected, the acceleration of both things must be the same. And that's also because the trailer doesn't have any thrust of its own. So that's the first part. Now the second part. Calculate the tension of the tow rope. So tension, force due to tension is also given by mass times the acceleration. And this is the mass of the trailer. So I'm going to call this one M1. So this is M1. So that's M2, and the mass that we did over here was M1 plus M2. Okay, so the acceleration is what we calculated before, 0.25 meters per second squared. So our force due to tension, our tension force, is 400 times 0.25, which gives us 1,000 newtons. And the last part of the question says calculate the net force. So the net force, F net, will just be given by 500 newtons of the thrust minus Ft, tension force, and that will be 500 minus 100, which is 400 newtons. Okay, so just remember that with Newton's third law, where every action has an equal and opposite reaction, this means that the force on one end of the rope, so over here, is going to be equal to the force at the other end. So all the way along here we have the same tension force. Okay, let's go on to another question.